There's more chairs up here, plenty of food left. My name is David Endler. I am the organizer of this Austin Hardware Startup Meetup. And by show of hands, how many of you have been to this meetup before? And so, by obvious process of elimination, first timers? Awesome, welcome. So, this is a very large group that is not represented here. I think we have almost 1,400 members in total. It's becoming almost a bit of a hardware renaissance in Austin. There's a lot of people working on exciting startups. There's a lot of service providers willing to help you get to market. Just knowing who to go to and hearing some of those founder stories is what we're all about. So we have an email list, if you can see it on the screen, wherever you are. This community is really warm and friendly, and so if you have a question about starting a company, if you have a question about a service provider or vendor, ask the list, and you typically find a bunch of helpful suggestions. So the typical format of our meetup is that we have a featured or guest presenter, one or two of them, and then we leave some time for questions, and then we have kind of an open mic announcements at the end if you're starting a company, if you're starting a Kickstarter, if you just want to introduce yourself. So, and then after that we can schmooze, get some more drink and food. So we typically start with some demos. We had a couple demos lined up, but both people had to back out. So in order to support them, I at least wanted to talk about some exciting things going on in our local community. So first and foremost, MakerArm, who made an announcement a couple of months ago, is actively on Kickstarter. Is anyone from MakerArm here? No, I didn't think so. So they are well on their way to blasting through their funding goal. But again, you should definitely check them out. Another local Kickstarter is from Super Mechanical. Super Mechanical, if you're not aware, was on Kickstarter with a project called Twine back in the day. And Twine was one of the first wildly successful Kickstarter projects. It was basically the first version of a connected sensor that worked with the internet. At the time, that was groundbreaking. And so they've gone on to do a lot of other projects. This is their latest, and it's essentially a remote connected thermometer that you can use in the grill or you can use in the kitchen. So check it out. One more is Mr. Hoverboard. Mr. Hoverboard presented here, I believe, back in December of last year. And Ryan Craven, the creator of Mr. Hoverboard, is now on not Kickstarter, but CrowdSupply, a platform for open hardware. And so check out the video at the very least, since Ryan actually is a film major and you'll enjoy it. The boards themselves actually take leaf blowers and you plug them in and it actually works. So without further ado, I'd like to introduce Scott Miller. As you'll notice from the picture, Scott is not wearing his Dragon Innovation shirt. It's because I couldn't find a good image of you that was high res enough that had a Dragon Innovation shirt. Are there Dragon Innovation shirts?
They're actually coming next week. We're going to get cool Dragon hoodies.
So for those of you who were here a couple months ago, we had Ben Einstein from Bolt. Scott is also a partner at Bolt as well. So he's doing a lot of exciting things. From Boston, he's been in the manufacturing game for a while. He's lived the war stories before most people even knew what manufacturing war stories were. I'm not going to read out his full bio, but he's got a wealth of experience from his days at iRoomba. I actually had to explain what iRoomba was, the device that you put cats on in shark outfits, and it results in funny memes. It cleans the floors as well.
It's a side product.
Right. Scott is renowned in the field for the hurdles from bringing a prototype all the way to production and market. He is a frequent speaker all around the world. We're very lucky to have him. I'd love to hand the floor over to Scott and hear about the manufacturing triangle. Please welcome Scott.
Great. Well, thanks, David. Really, really excited to be here tonight with you. We'll get it queued up. So as that's loading, I like to keep this super informal. So please, as we go along, don't be afraid to interrupt, raise your hand, ask questions about anything we're talking about, or if you've got stories and been through this before, feel free to share. It's a lot more fun if it's interactive. So in terms of what we're going to talk about, before we get that, I'm going to get in the back half a little, I wouldn't call it technical, but a little bit more detailed stuff, which will hopefully give you some good tools and framework to be able to build and bring to life your hardware products. If you find it interesting, feel free to take a picture of this, and all the slides will be uploaded here. And then I also gave a copy to David so that you can get easy access to that stuff. So in terms of what we'll talk about, I'll start with a quick survey. I always find it fascinating just to see who's in the audience and who comes to this, and then split it into two main parts. The first part is sort of the our hardware journey, trying to put into context why cost, quality, and schedule are so important, because kind of in abstract, they're a little bit less interesting. And then hopefully, as I've shown through the story, that they're relevant, then I'll break down for you in part two of actually how to use each one of them to your advantage and why they're so critical to your success. And then at the end, we'll have a bunch of questions and answers. And realizing we've got about an hour, I'm going to try to go a little bit quickly through the presentation stuff to leave more time for the Q&A, because I think that's the more interesting part of it. But that said, slow me down if I get going too fast. So for the quick survey, just by a show of hands, how many people have built a working prototype before? All right, not too surprising. Has anybody built and sold more than 5,000 units? All right, can I get 50,000? All right, 500,000. Very cool. What was your product?
A battery for the clock in desktops back in the day.
Okay.
Was one. Another was two products that were consumer battery chargers.
Okay, and what sort of, were you in the millions, or what sort of volume were you looking at?
Battery chargers were in the millions. The computer clock battery, probably about 35 million lifetime.
That's awesome. Yeah, it's a fun rush. Cool.
I did 10,000 units just to do validation work.
Wow, what sort of product was that?
This is to validate SoC chips
Okay.
and to, develop the infrastructure of all the components that go, let's say, in a tablet, all the cameras, the Wi-Fi, the LTE, all that sort of stuff. It just takes a lot of units out there through different iterations of design to get it. So it went into production, but it never sold.
Yeah, I mean, that's the thing with manufacturing, is it's such a long journey to get there.
Yeah.
But once you're, as we'll talk a little bit more about with the Roomba, once you walk into a store and see somebody pick up something you've built and sort of watch them play with it and then hopefully bring it to the cash register, it's a sweet rush. It's definitely worth it. But it's a long process to get to that point. Cool, well that's helpful. Okay, so part one, sort of the quick journey. I thought it might be useful just to give you a few minutes just on my background, so you can see kind of where I came from. So I'm a mechanical engineer by training. I've always loved robotics. Was really lucky to work on a full-size robotic tuna fish, looking at more efficient means of propulsion using active vortex control. So this one is actually about the right size. It was 6 degrees of freedom, and she could swim really well in a straight line. We used to inject red food coloring to be able to visualize the different streak lines. And at the end of the day, it looked like the poor thing had been harpooned going up and down the tow tank of a pool. But it was a great way to get started. From there, jumped over to Disney, which is one of the most fun jobs I've ever had. And this was right after I graduated, so I sort of assumed every job would be like this. But we did many things, but the most memorable was being tasked with building a full-size walking dinosaur. And this was back in the mid-90s. So if you think of how primitive the tools were back then. So for example, as we were designing sort of the dino and a little bit before that, the fish, there was no 3D solid modeling. We would, in Ashlar Vellum, print 2D parts and then hold them up to make sure all the holes lined up before we had a machine. And everything was just plainer sheets of aluminum stock. There's no fancy 3D curves and stuff like that. And that was only, I'm not that old, but that was just 20 years ago. It wasn't that long ago. And if you think of what we can do today with Onshape, it boggles the mind. But for our girl here, she was about 12 feet tall, 12 feet long, 12,000 pounds, 12 degrees of freedom. You can see a chair for reference and full sensor payload on the feet, so she could actively walk, detect potholes, and all of that good stuff. And we powered her by a Corvette engine. So that was definitely a lot of fun. There's only one of her, though. From there, as it gets relevant to tonight, jumped over to iRobot for 10 great years. This was starting in the late 90s. And when I joined, we were really good at building $100,000 robots for the US military. And with that, as we'll talk about, there's three things that we care about for manufacturing: cost, quality, and schedule. With that, we had quite a bit of margin on the cost. We could buy $5,000 motors, which are just beautiful. They solve a lot of problems. Whereas when you get into consumer electronics, you're going to work with a 50-cent motor, which is a lot less beautiful, and you've got to overcome it in different ways. But you just can't spend your way out of it, or you can't solve problems by spending. So we're really good at that. But the problem was the market is just way too small, and Colin's goal was always to go public. And we knew we weren't going to get there on just that robot. So we had to figure out what to do. And as we were trying to figure this out, people would come to us and be like, hey, I don't know what you guys do, but you have robot in your name. You should build a robot that either brings me a beer or cleans my floor. I thought, all right, well, let's focus on the floor cleaning first. So we did that. It's like, all right, that's awesome. We're going to build a floor cleaning robot. But I guess we're smart enough at the time to realize we had no clue on how to do that. And in particular, we knew that going from a $100,000 robot to, say, a $50 cost of goods robot, which is what the first Roomba cost, of which $13 was the battery, was an insanely hard task. So the way we solved it is partnering with Hasbro, who is just down the road from us in Pawtucket, Rhode Island, realizing that in the toy world, they're really good at building high-quality, low-cost products on a schedule. And these will be themes we'll come back to. But with any toy, if you miss the holiday season, you have to wait another year before you get a bite at the apple. So that's going to make a huge impact on your revenue and being a public company. There's ramifications to be had if you're late. So we thought, okay, these guys know something we don't. Let's work with them and learn as much as we can. So we built this freaky baby doll using, again, it's like late 90s, so there's no fancy curved parts. It's just all planar things kind of bolted together. And in the process of working with them, learned a huge amount, which eventually ended up with my real baby over here, where we sold about 100,000 of them. And initially we thought, well, shoot, 100,000 is a lot of product. It probably would fill up all this space. But in actuality, we totally blew a huge opportunity. We easily could have shipped 1 million of these, if not more. We were able to, with $28, build a 4-degree of freedom robot with a full capacitive sensing bodysuit. We couldn't afford accelerometers because they were too expensive, so we made what's called a ball and cage, which is a ball in a cage, to figure out her position. The problem we hit is a few-fold. One is we decided, being good engineers, we're going to do everything from scratch and not reuse anything. So obviously in your building high-volume toys or consumer goods, you've got to do all mechanical from scratch. Like, that's always custom. The same thing with electrical. We thought, well, let's do the software too. We're not going to use C, we're going to write our own language. So we ended up building this variant on Lisp, so you can imagine all the parentheses. And it was called Toy Language. So we were trying to get all this stuff debugged and coming together at the same time for our first product 15 years ago. And instead of launching in July, which is what Mattel did, with an inferior product, but they were able to market it very effectively, we didn't launch until November. And that was just too late. All of our target was 8-year-old girls. They had all made up their mind, and the Mattel doll was on their holiday list. So we squandered a huge opportunity, which is something I'll never forget. It bothers me to this day, but we squandered it because we were late. So we'll talk more about schedule, but as you think of consumer electronics, which is where my background is, you absolutely cannot be late. So I'll try to give you later some techniques on how to make sure you're tracking on schedule and you miss that. Because if you are late, thinking that most companies here are startups and cash is king, and if your sales are exponential and you can only sell in the holiday season and you miss it, you've got to wait a whole year. So you have to be able to survive that burn for a year without going out of business. So it's really deadly if you miss an opportunity. And that one was just burned into us. It was insanely painful because we worked so hard on that. Like, this is, as with all startups, sleeping on the couch for days on end, just trying to get this thing to work. But we got her work, well, at least we got her in the market. We built some more dinosaurs and other stuff, and we're able to learn a little bit, which brought us to the Roomba. So based on that, my job was to take the Roomba, which was a working prototype, just imagine like $25,000 of SLA at the time, and figure out, now that we've got one of these, how do we make a lot more of them? And at that point, we were on our own. Hasbro had, was working on their own other toys. So I just remember being the first guy getting on a plane, going to China, and trying to figure out how do you pick a great factory. And that's really, of all the things you're going to do, that's the most important thing you can do. And living, like, how hard is it to even find what factories to talk to? How do you get their attention and all that? But we figured it out, and that's sort of what we call today the RFQ process. And if you're interested, we can definitely talk about that more afterwards on some best practices for it. But we found the factory, we're able to build the Roomba, and the biggest challenge we had is that the demand was insane. We thought we'd build 25,000 of them, and that seemed like a lot. It's a pretty big number of robots. But for the first 2 years, we literally could not build them fast enough. The problem was, how do we get more tools? How do we deal with multiple cavity configurations to make sure there's not strange tolerance stack-ups? So it's a really strange problem, but we were lucky and we hit it. So we thought, okay, we got the Roomba going. That's going to get us part of the way to going public, which was always the goal. What are we going to do now? And it seemed like the obvious thing to do was a wet mopping robot, which is the scuba on the right. I'm always curious to see, like, how many people have heard of the Roomba before? Okay, how many have heard of the scuba? Haha, there you go. Yeah, so we thought, this is brilliant. Everybody's going to love the floor washing robot because it's such a pain in the butt to get the mop and bucket clean the floor. So and it's a much, much, much more complex robot because you're dealing with liquids, you're putting down soap and then trying to drive around in the soap, which is slippery. Like, this traction alone was hundreds of thousands of dollars spent trying to figure that one out. So we launched it. We were almost late. Like, we IPO'd in like middle of December, and we started shipping this around Thanksgiving. So, if you think of a 5-year development program, like, we almost blew it again, but somehow we got the thing out. And we had the opposite problem we hit with Roomba, is that nobody bought the thing. It just fell flat. And we were so puzzled, like, how did this happen? And as we pulled back the onion a little bit, we realized that with a vacuum, we're competing a $200 vacuum with a $200 robot. That's fair. With the mop and bucket, we're competing a $400 robot with a $10 mop and bucket. So things like crowdfunding today would have solved that problem, and it's so obvious, like, in retrospect, like, how could we have been so stupid? But being able to pre-sale and so on, we've got a lot better tools in our toolbox to avoid those mistakes. And eventually, when we did lower the price, which is what I'll show you on when we talk about cost of goods sold, is how to get your COGS down. The volume went up to a much more interesting level. So as you think about putting together your business model, if you don't have good control of your COGS, you're really most likely not going to be able to realize the full economic potential of your business. So you've got to deeply understand that stuff. And that brought us to Dragon and Bolt about 6 years ago, where what we try to do is make manufacturing feel easy and shed light on it. So that's sort of the overview. In terms of diving into some of the details, so everybody says manufacturing is hard. And for the folks in the room that have built 35 million or 10,000 just for validation, like, you've been down this road, you know it. But I thought it might be useful sort of to take a look at a factory and try to visually show some of the reasons why it's so challenging. So what happens in the next slide is back in 2005, I grabbed a little camera and just ran down the Roomba line. So you'll see what that looks like. Yeah, let's see. Hopefully it will launch here. Well, she might not be with us today. But basically imagine this for like 5 football fields. So we had roughly 5,000 workers. None of them speak English. Actually nobody in the world had really seen what a vacuuming robot is. And if you pull it back a little bit, when we designed it, we had 8 engineers in Somerville, Mass, who all spoke English in a small room doing this day in and day out for many, many years. So take that design and then translate it halfway across the world to people that, like everybody else in the world, have never seen a vacuuming robot, where we're really pushing the limits of what you can do. So we had, excluding the battery, $38 of stuff. So we significantly cost reduced it. And the design was in no way, shape, or form baked. Like we were changing stuff left and right. We were touching the tools as we were shipping the product. None of it was recorded. There was no ECO, ECN. It was just the Wild West. There was no quality control. Somehow we pulled it off, and there's a lot of horror stories where we thought we were going to die the night before, and then somehow we solved it. Just day in and day out, it was like that. And then we're trying to build more and more and more of them. So hopefully, and I wish the video ran. I'll show you later if you want to see. I can put it on my machine. But that's some of the reason manufacturing is hard. Looking at it, kind of breaking it down a step further, is that as we're talking about, you have these cost of goods sold, which will really make or break your business. Usually in manufacturing, or in consumer electronics, you want to have the retail price be 4 times what the cost of goods sold is to be able to have sufficient margin. And I'll talk about that more in a sec. But you've got to understand COGS. You also have tooling. So what makes the plastic is these giant chunks of steel. They have lead times. If you think of the lead times, that's going to impact your schedule, which might impact whether you can make the holiday season or not. You're going to have really significant quality problems. With every Roomba, it plugs into the wall. There's a lot of power in the wall. If you're building 1 million a year, it just needs 1 in 1 million to have a mistake that creates a fire that burns somebody's house down. How do you design against that to protect yourself while also hitting your cost and schedule targets? So it really starts to get complex. You've got this thing designed for manufacture and assembly. So just because you can build one on a MakerBot, that's awesome. But how do you take that and design it so that it can be built 7,500 a week in an injection molded press? That's a whole different ball of wax. Same thing with the electrical side. Often if you orient capacitors the wrong way, they're going to crack. And they can actually crack in a way that they create a fire. So how do you, deal with all that stuff? Scaling the team, and then this is just manufacturing. You could throw in logistics. So how do you get the product from Shenzhen over to Austin if that's where you're selling? How do you deal with the retail channels? Like it's just one of these fractals where the more you break it apart, the more complexity it is. So manufacturing is pretty hard. The trick is how can we shed light on that and make it more of a repeatable process? And also, how do we bucketize it into things we can control? So that's where we get to the cost, quality, schedule, which is where I always start. Just understand and control those 3 things, and you're going to be okay. So what I'll do now in the back half of this is just dive into one of those. And I'm going to focus the most on COGS, or cost of goods sold. So we'll spend quite a bit of cycles on this. So what is the cost of goods sold? When we look at it, it's the direct cost for building the product that you're going to pay the factory for. Now, there's a couple of different places you could pick it up. For me, I always deal with X factory, or XF, which is what I control, which is a product sitting on the loading dock in a factory in Austin and Shenzhen and Juarez, take your pick. But it also could be the FOB, or freight on board cost, of what it costs to take it from the factory and transport it to the boat. Or it could be the landed cost of what it takes, the FOB plus the on the water or in the air cost. So as you're talking about this, you want to understand where in the cycle you're picking it up so you can account for all of those costs. The other thing is COGS varies over time. So it's very rare that you build a product and it doesn't change, especially if you're a startup. You're going to be learning a lot of things. You probably haven't had a big engineering team to start with, so things may be not quite as baked as they should be. And you're going to do sustaining engineering to reduce the cost and improve the quality. But as you do that, there's going to be, like the Roomba we had, I think 1,500 parts in it, mostly electronics. As we're changing out, and we always did rolling changes, just changing everything asynchronously, you're going to have one batch with some components, and another batch is going to have different components, and then another one's going to have different components. How do you keep track of all that stuff? So you just want to be very clear what, when you're talking about COGS, or cost of goods sold, where it is and what version it is. And then just to make it more complex, if you think of resin, which is the plastic that makes the shell, resin comes from oil. Oil is a commodity and the price goes up and down. So did the factory buy ahead? Did they have to pay extra to buy it on the open market? What impact of the cost is that? And as you're shipping, say 1 million units a year, every penny you save is $10,000. So there's pretty big leverage on it. This is this incredibly simple retail model, and if there's anybody on the retail side, apologies, it's super simplified. But you've got your cost of goods sold, and then you've got to make money. So we typically say you'd want to double the price. And then that's where you'd sell it to, say, the Best Buy. And then the Best Buy is going to often want 50 points. And then that would be the price that they sell it to the consumer. So this is a very rough rule of thumb. And it only also works in one direction. But when I go to a store and look at something, if it's $100, in the back of my mind, I think, well, it better cost $25 or less to make. If not, the company's going to have trouble being profitable, unless it's a different business model. Sometimes today, given the low cost of radios and the ability to get data into the cloud and the usefulness of the data, you almost will give away the hardware at cost just to get the data and do something interesting with it. And if that's your model, that's awesome. But if that's not your model, you're going to get killed if you don't have something similar to this. The thing that you shouldn't do is say that it cost me $10 to build this product, therefore I can sell it for 40. The logic doesn't work that way, because the consumer may pay $200 for it, or they may pay $5 for it. So that's more of a marketing issue. But if you just work backwards from what you see in the shelf as a rough rule of thumb, what the cost of goods sold should be, that hopefully that will be a useful trick. So what drives the COGS? And there's a whole bunch of stuff here, which I'll let you read. What I'm going to focus on is what killed us on the Scuba, and that's what we call the pack out. So the pack out is, in this case of the Scuba, the robot, we had a spare battery charger, we had a couple virtual walls, we had the scuba juice, we had a brush to clean it, and all this other crap in there. And everything you add adds money, it makes the packaging bigger, so that costs more on that, and it increases the logistics cost. We found that we didn't have to make any changes to the robot. We just stripped out the other stuff and sold it as an accessory and made great money on it. And that brought a $400 robot to a $250 robot that went from not moving at all to flying off the shelf. So the quickest way to save money is to put less stuff in the box. It's by far the easiest thing to do. And again, I'm the manufacturing guy, not the marketing or retail person. So you've got to put enough in the box so that somebody wants to buy it and sees the features and the value. But so often we see startups get so excited they want to do a great job for their customers, which is incredibly important, but they'll put everything in the kitchen sink in there when they actually don't have to do that. Or they could just sell the other stuff as accessories and make a lot more money. So when you think about saving money, I always start with the pack out as one. And then the second thing is the box. We used to work with a great company who was our first customer called Zeo, which was doing some pretty innovative stuff in measuring your sleep. You'd wear sort of this dorky headband, but it could get your deep sleep, light sleep, REM, and awake, and do all sorts of analysis to it. Their X factory cost was about $50. Of that, $7 was the box. And they were selling direct, so the box wasn't even a marketing tool. It was just a container to ship the thing. People would look at it as this giant origami experiment that they'd unfold, be like, cool box, throw the box away and go use the product. They ended up going bankrupt, unfortunately. Partly because the cost of goods sold was too high. But if they had got the COGS from $50 to $43 and spent $1 on the box, I don't know that they'd still be in business, but they would have had a lot healthier margins. So really think before you get worked up and try to be Apple with your box. Think about what you really need. And often if you're selling direct, the person has already bought the thing, so you don't need a lot of 4-color, UV-coated origami boxes. Like a brown shipper might be enough. And again, I'm the manufacturing guy, so it's got to be balanced with appropriate marketing. But we really see many companies swinging too far for a lot of stuff they don't need that people are going to throw out. So between pack out and box, it should be easy to take out some money. Now, the whole trick for controlling cost is to understand your costs. So this starts with the bill of materials, which I'm going to talk about in a little bit. But you really want to get down to the molecular level. If you get a quote from a factory and it's just one number saying, to build this microphone is $50, that's useless. Like, you don't know if you're getting a good price or a bad price. What you want to do is provide them a very detailed bill of materials with line-by-line items, and then have them quote against that. Because otherwise they're going to add mystery meat in all the little spots, and it's going to be very difficult for you to tease that stuff out. So you really want to have it all mathematically driven. And again, we'll come back to the bombs in a sec, so that you have very, very good clarity and precision and resolution on what's going on in there. And then that also lets you compare it to standards. So if you know your Bluetooth module costs $4, or you think it should cost $4 and they're charging you $10, that'd be a great thing to talk about. And maybe they're giving you a much more capable radio than what you need, but maybe they've stuck a lot of fat in there that that you don't need. You also want to include on the COGS, negotiate what's included. So are they including the stencils and the test fixtures and the in-circuit test stuff, or are they going to charge you for that separately? And it doesn't matter one way or the other, like you can negotiate, but you don't want to be surprised. You want to understand what's in it. So, in terms of some strategies to get the COGS down, and again, often the healthier business depends on controlling your COGS so that you can get that volume. Step one is get the transparency. And the best way we found to do that is to give the factory the bill of materials rather than having them provide you a quote on their template. An area where we often see a lot of inflation is on the labor rates. And does anybody have any idea, if you get a price for $8 of labor on a product, how you would go and negotiate that and prove to the factory that it's either fair or too high?
You have to figure out the complexity of what you're building, how long does it take, how many tool changes are they going to be doing, how structured, how easy to assemble is the product.
Exactly. Yep, yeah, and it's all about getting that atomic or molecular resolution. So you want to break the labor down, ideally component by component. So think of our pack out, and I'll use the Scuba Roomba as an example. We got a couple virtual walls. How much labor is in each virtual wall? What we often do is we'll make an assumption on the labor rate. So we work around the world, but we do a lot of stuff in China, and I know the labor rate there is $4 to $8 an hour, depending on the quality of the factory. So what we can do is count the number of products coming off the line and the number of workers on the line, and then just do simple math and see, does that roughly, are we in the ballpark of $4 an hour, or is it $40 an hour? And the way the BOM works is, and I'll talk about this a little bit later, but the factory will apply their markup on top of the labor, so they get to double dip, and that's understood. But the more they can inflate the labor, the better, the happier they're going to be. So that's an area where it's not like arguing over the cost of a Bluetooth radio. It's a lot squishier, but we always see them adding inflation in there. So you'd want to go after that. It's great to have a standard cost database of what things should cost. So if you've worked with other people that have built things, you can compare your BOM with what they've got costed. At Dragon, we've got a database of every component we've ever seen, so we can figure out what's a reasonable cost and which ones are outliers. Obviously, if you can get multiple vendors, that's great because you have leverage. Otherwise, you're sort of you're stuck with what you have. And whenever you can get leverage, as I say there, it is a beautiful word. It's an awesome thing to have, and you get it at different times in the cycle. So you want to be aware of when you can get leverage and then leverage that leverage. And as we talked about, in low volumes, a little bit of COGS increase doesn't matter. But as you start to build up 35 million, every little penny has a phenomenal impact. So those are a few strategies. What we often find is folks don't have a good understanding of how do you even calculate the cost of a basic piece of plastic. So imagine you've built something with a clamshell, it's got a top and bottom. How much does that plastic really cost? So what I'll do here is just walk you through a super simple calculation. And I use a gear as an example because it's a precision molded part. And I always ask, does it matter that it's a gear or not? In some ways it doesn't really matter at all, in other ways it does. The ways that it matters that it's a gear is you're probably going to need to use a more expensive resin like POM or Delrin or something like that to get the mechanical properties you need. So that's going to add a little bit of cost. You're probably going to need longer cycle time because you want it to cool slowly so you don't get sink marks. And you'll probably need more gates, injecting the plastic into the part so you get an even cooling. But the geometry doesn't matter at all. The part, it doesn't care whether it's a gear or anything else. That's going to be covered on the cost of your tooling, which is a whole different conversation. So, with injection molding, this is a longer topic, but complexity is in a sense free. So the fact that it's a gear in the geometry sense doesn't matter. So there's three things you got to do. One, to understand the cost, you have to figure out how much does the resin cost. So that would be the sum of the cavity plus the runner and kind of the plumbing that gets it in there. So you can figure that out by your CAD file. You'll have the volume or the weight. You can look up online what the resins cost. Generally, plastic's about $1 a pound, although it does vary a little bit. And I think later I give you some reference parts. What's the overhead of running the machine? So how much does the maintenance and the electricity and the oil and all of that cost to run it on an hourly basis? And I'll give you some numbers there. And then you can just do the simple math to figure out for every shot. Usually you get a shot roughly every 45 seconds. You know, how much is that part costing you? And then what's the factory's markup? So if you add the material cost and the overhead cost together and multiply by 1 plus the markup, you have the price of your plastic part. So to make this more concrete, let's say I have 50 cents of resin and the overhead of running my machine is 50 cents. So that's $1 and my markup's 15%. So my part is going to be $1.15. So with these super basic tools, you should be able to calculate what the plastic costs in the parts that you're building and take out the mystery of it a little bit. So these are just some, like that's the formula. This is the data you plug in. So these are the different resins we use. If you're interested, again, remember resins are oil. Oil's a commodity. The price is going to change. You can just go to that site and you create a simple login, but they won't spam or bother you. This one was, I guess I did the talk in 2013 when I put this in, but like ABS you use for your housings. It's a good all-purpose material. PA's nylon, high density and low density. Polyethylene is good for like, high density is good for like milk containers and things like that. But those are kind of the basic resins that you use. And you want to figure out, what's the appropriate resin, but then you can just plug in the right price to that formula, which is the first half of the equation. And then the second half is the overhead, or how much does it cost to run the machine. And these are just taken some characteristic values for running molds, running injection tools in China. So if you're running on a 80-ton press, which would probably do a part maybe as big as my hand, you're going to pay a little more than $5 an hour. So if you just plug these numbers into that simple formula, you can calculate, what your plastic costs as a starting point. And now I'll let you validate that the factory is giving you a fair price for the plastic. Because if you don't do this, hopefully they're not charging you more, but you won't know, and the whole point is transparency and understanding. So that's the mechanical part of it. Electrical is much simpler. It's just on the most basic level, the number of components times the price of the component gives you your extended cost. Where it gets a little more complex and something the factory will never do, but you should do is you give them the bill of materials, is as you think about it, I had alluded to the factory is going to apply a markup to everything they touch. So you might say, well, Scott, for 1/10 of a penny resistor, I don't care what the markup is, that's fine, it doesn't move the needle. But if I have say a $20 radio, I don't really want to pay 15% markup on that because it's the same amount of effort to place that as it is the 1/10 of a penny resistor. And if you did that, you'd be exactly right. So what we do is we say everything over a threshold, and for me, my threshold's $1. I want the factory to charge a special markup. Everything under a threshold, charge your normal markup, I don't care. And we'll negotiate those separately. So that way, if you've got like batteries, the Roomba battery I think got up to $32. Like there's no way I'm gonna pay 15% on top of that. I wanna pay a fixed cost that I'll negotiate. Like, for the dealing with the cash and putting it in a humidity controlled storage, I'll give you $1 for it. But that's where you get just tremendous savings, is by separating stuff with this threshold. So you want to build that into your BOM, and that's something we see most people don't do. In terms of what are the standard markups we see, so just bear the PCB is the circuit board or printed circuit board. The PCBA is the board with the stuff on it. For PCBAs, if you're just getting populated boards, we typically see 6 to 8%. So again, you take the cost of components, you add the labor, put it together, and then multiply that sum by 1.06 or 1.08. For toys, you're looking at about 12%. Consumer electronics is 15 to 20%. and the medical can be anywhere from 40% to 300 or 400%. You know, if you look at a little, one of the factories we work with makes blood warmers, and you think, oh, you know, that's cool. That seems like it should be expensive. But the whole trick is just get it to the atomic level. It's a piece of die-cast zinc or something like that with a coating and a piece of plastic on it. You can figure out, based on what I told you, how to calculate how much those costs are and then apply their margin to it. So when you do that, you realize that they're charging like 400 times on top of the materials. So you just want to take the mystery out of it, or just get to the very atomic level. It doesn't matter that, in a sense, that it's a blood warmer. Maybe there's a cost, or hopefully there's a cost for sterilization, but you can figure out what that is. How much does it cost for the maintenance of the clean room and for the electricity and the HVAC system? Like, just break it down to very basic principles. So that's sort of the theory of COGS and some strategies. What all of this stuff is based on is the bill of materials or the BOM. And in working with hundreds of startups, the thing we see consistently is that every company has a different BOM. There's no universal format. People often, like, we work with a bunch of folks at Apple, they're like, oh yeah, I'm just using what we had there, or whatever other company. But it's really hard, like, if you were gonna Google canonical BOM or like standard BOM format, you probably wouldn't find anything. So we did a quick survey, that's on the next site. You know, what type of tools do often startups use? And we found that most of them would typically use Excel or Google Sheets. And those are pretty good tools. But when you consider the BOM is like the skeleton of everything you're going to do. It's going to generate your cost of goods sold. It's going to generate your cash flow. So when do you have to pay for the components? You might build a approved vendor list off it. Everything is hung off the BOM. That it seems, in retrospect, crazy not to have a standard format that's solid. So what we've done at Dragon for the community, and we'll launch next week, just as a Google add-on in the store, is a standard BOM tool to try to give folks something that covers the right amount of data that you need in the right format and some very basic part numbering. So you just download the thing, it will create your purchase parts, fabricated parts, PCBA, and so on, and then just give you some examples. We can run some analytics for you so you can see quickly how much is electrical components, how much is plastic, and what have you. And again, it's a free thing out there, but hopefully it will help companies be a little bit more efficient as they generate a BOM and then give that BOM to a factory so they can put forward a professional appearance.
So is that going to show up in Google Apps?
It'll be if you go to Sheets and then the add-on store, I think it just search for Dragon BOM, and it'll just load in there. And we would really love any feedback you have on it, but we just see so many companies struggle with it, and it's so important to get right that we thought it might be useful to get it out there. And again, it's a pretty simple thing, but hopefully it will help. So we have three parts. That's the costing or COGS part of it. Next one is schedule. And a lot of this we talked about. You know, if you think of your revenue or your sales, every day you're late, you lose that big bar. And that's incredibly important if you're a startup and have a burn. So what we see is everybody is always rushed. And the beautiful thing of this is cost, quality, and schedule all kind of flow together, that you're always making trade-offs. Like, if you didn't have to test things as much, then you could ship sooner, but you might get bit in the ass if your quality's not good. Or if you could pay twice as much for your motors, you'd have a lot less quality issues and you could ship sooner because you don't need to do as much engineering making a bad motor act good. But the whole trick with schedule is figuring out, what are your key dates? In our world, it's usually actually two things. One is holiday season, and then the second is CES. And unfortunately, they're kind of put close to each other. But if you miss those two, it's a long time before the next one comes around. So step one is figure out what are your dates, and then step two is put together a comprehensive schedule. We've got in our Dragon schedule, I think, 197 different milestones or different things that may need to be done. So just understanding them, and then the duration from when I release the tools, how long does it take before I've got my first shots? How long does it take to do the engineering pilot? This is sort of a super high level kind of walking around from creating a prototype to OBS's onboard ship. So when you actually have products in the can, and it does depend on the complexity. And given the amount of time we have, I won't dwell on this too much, but if you break it down, like figure out what are your key dates and then what are the different steps you need to get to those dates, and then track, and if anything goes late, just remember hope is not a strategy, at least in manufacturing, although we all, at times we need to jump into that. But if something's late, you've got to take corrective action and figure out how to get it on track. It won't do it on its own. And these are, even pulling back the onion a little bit more, some of the different steps in the process. So I won't dwell on it, but if you're interested, feel free to download it and take a look. And then for quality. So you probably don't want to be this guy. Does anybody know who he is? Or more importantly, what company he works for? So this was the head of Toyota when all the recalls happened. And it just, the worst, we had so many, geez, we're screwed, it's over moments at iRobot. Like, I know that feeling. Like, you've worked so hard to get this thing working, and then you shipped a bunch of product, you're so proud to get it out there, and you get the email from the factory, and it's like, oh, guess what, we found this failure mode. It's like, oh, how can this be? I mean, it's a drama every day, but there's nothing worse than like the pit of your stomach when you realize you have a quality issue that's not through. And inevitably, again, remembering cost, quality, and schedule all go hand in hand. You're never going to have enough time to test something as thoroughly as you want to. You probably may not have put together a comprehensive enough quality plan that things are going to slip through the net. So it would be, we can talk about quality for hours, but we only have a few minutes. So it boils down to, for me, the last thing here, which is, you're sitting in your office, wherever it is, you get a note from the factory saying, hey, Scott, we used to build 40,000 Roombas a week, so 10 containers of Roombas a week. We built these 40,000 containers, is it okay to release them? And it's a super simple thing. It's like, it's yes or it's no. But if you get it wrong, you've just bankrupted the company. So to put it in more context, say a Roomba's $100, so 40,000 Roombas a week is $4 million. And it takes 10 weeks from when it leaves the dock until when it gets to the consumer's hands. So that's $40 million you get tied up. Then if the consumer's the one calling you on the phone saying they would do it, but like, hey Scott, my Roomba doesn't work, like that's $40 million. We just bankrupted ourselves. So you've got to be able to answer that question when you get it with confidence. And as with war, there's always the fog of war or the fog of production. Like, you're never going to be 100% one way or the other, at least as a startup. So how do you put the processes in place? So with as much confidence as you have, with your limited budget, with your tight schedule, you can say, yeah, we're good, let's do it, or let's go and rework the stuff. But I always start at that point, and then you can work backwards from there to figure out what questions you should be asking and when you should be asking them, so you can answer with confidence. And quality, again, we can go on forever on that, but in the scope that we have, just maybe frame it in that sense. What I'll do is just wrap up here. We build a lot in China, although we're always agnostic. The trick is just finding the best factory location and factory for what you're trying to build. But if you do end up building in China, I found these books really interesting, and personally I find China fascinating. The first one is What It's Like to Be the Life of a Factory Worker, sort of looking through their eyes, written by Leslie, who's a Wall Street Journal reporter. So she's just beautifully articulate, and I think it's about a 500-page tome, but it's pretty cool to see what the largest migrant workforce in the world is like. Second one is funny and frightening in the same sense. A lot of things just gone terribly wrong that they can write about. And then the third one is sort of old school. It's 20 years ago, the first guy, or one of the first guys that moved over to China to help people build products, and all the different calamities and adventures he had. So I thought you might find those interesting. I think with that, I'll stop talking here, and I'd love to hear any questions you have, either now or you can always catch me afterwards or email me at Scott@Dragon Innovation. Yeah, we'll go from there. So I'll open it up to the floor if you have any questions.
How do you know when to stop pushing on your manufacturers, when to stop beating up on them on price? How do you know when they're starting to get uncomfortable to the point that it might start affecting your own quality and timeline and things like that?
Yeah, I mean, it's a total balancing act, and it's really, I've never found banging a shoe on the table works, because it's a much bigger partnership where, like, you've got to have a very tight relationship with the factory. Where I find a lot of the problems get solved is if you have a good bond that's transparent, because we can debate, whether this Bluetooth module should cost $4 or $5. Like, there's data to support it. But if we do it at the bottom line, the factory's saying this product costs $12, and I say no, it should cost $8. Like, it's just their opinion or my opinion. So just get it as scientific as you can. And say, for example, like a piece of plastic. It's just a mathematically driven equation that we can argue over the price of resin or the overhead of the machine, but at least it breaks it down into things that are more discrete instead of an opinion thing. The other thing to keep in mind is if you're Apple building a ridiculous number, you have that magic word leverage. If you're a startup, you're probably lucky to be working with a factory that will give their capability and the opportunity cost where they could be working with somebody else because it's super risky. So you probably want to push them a lot, get it fair, get it close, but it's better to spend time on schedule and quality than it is to beat them up on price until you've got volume. And from a leverage standpoint, up until the point you assign, or pick a factory, you've got all the leverage you need. The minute you sign with the factory, you have no leverage until you're shipping product. And then you start to gain leverage again as your volume comes up again. So sort of figure out where you are in the cycle. If you're in the no leverage point, then hopefully you've lined it up so it's all mathematically driven and you've got good visibility to it. But otherwise, it's going to be really hard to get them to do anything they don't want to do. And this is all kind of predicated on that you pick a great factory. If you pick a lousy factory, it's incredibly hard to win.
How do you deal with, you're going to receive shipments that don't match your quality expectations?
Yep.
How do you deal with that particular problem?
Scott?
Yeah.
Can you please repeat the question?
Oh, absolutely. Yep. So the question is, if you receive shipments that don't match up with your with your expectations, how do you deal with it? So yeah, that can be a really sticky wicket. And the problem is
You've got to make deliveries.
Exactly. It's going to mess up your schedule. And we talked about the importance of hitting schedule. And the problem is, if you build in China, they're already over here. You probably don't want to rework it because our labor rates are so high, and it's hard to validate the quality again. So what we find is having a comprehensive quality plan that does what you need it to do, but it's not over the top. Like if you have a really bloated plan, it's going to kill your price because they're going to charge you too much money. But knowing kind of what you have to testing for, and then validating along the way. So we would often do like SPC or statistic process control on every station, monitor that very carefully so we know if something's coming out of spec. Final inspection using an AQL or acceptable quality basis to do a statistical process before they release the shipments. And then in the manufacturing service agreement have sort of well thought out clauses. If it doesn't match the expectation, what happens. So that you want to think about it all ahead of time as opposed to being reactionary. And then we always are huge believers of feet in the ground in the factory, whether it's in Austin or in Shenzhen. So you've got eyes and ears that you trust and get that high bandwidth connection. It is critical just to close the loop.
On your schedule, we're so software dependent. How do you integrate in the software timetable, with the hardware and stuff like that? How does that fit in?
Yes, so what we find is, so how do you integrate in the software schedule with the hardware is the question, the hardware schedule. At Dragon, definitely we focus on the hardware, or the electrical and mechanical part of it. What we find is that a lot of it depends on your strategy for how is the software loaded on the chip. So what we find works is if you use a bootloader, so in say like a company like Avnet based in Hong Kong, you can create a secure part of the code where you can squirt encrypted code, and then you take that chip and consign it to the factory so that you can basically just keep giving them new code without having to worry about somebody stealing it, and then leave time for regression testing, life testing, and everything else that the code should require. And then from that point, backing out what your software schedule needs to be. It's an interesting question. When we did the first Roomba, we had something called mask ROM, which is like ROM that you can't change the code. It's a 12-week lead time where you give them the code and then if you screw it up, you're done. What happens in practice is you solve software problems in electrical components to change things. But we found our code was 1,000 times better than when we went to Flash, because in Flash we would just squirt it in willy-nilly. We wouldn't test anything, and it would just be a mess. So definitely having the appropriate software tests in place, and understanding, when is the last time I can inject it and test it before we ship it is critical.
A really basic question, but when you're starting out with this factory research, like how do you start that process?
Yeah, that's a great question. So it's when you're trying to find a factory, how do you go about that? And we would look at that as the RFQ process. And we've got, if you go to the Dragons Innovation slide, share a bunch of talks on that. The most important thing you'll do is pick the right factory. You're definitely not gonna, your chance of finding it on Alibaba is incredibly slim. There's good factories there, but there's so many factories that are not good. And we've seen a dearth in the market of good ways to do it. So we developed a kind of a dragon-proven process for going out and vetting the factories. We've got about 1,000 in the database and sort of a methodical process for how do you work through it. So we can always help with that, and the presentation will go into more detail, but basically there's 3 parts. One is you create an RFQ package, which in itself has 3 parts. An overview of the company, the bill of materials in canonical fill-in-the-blank format. So all of the separating out the high and the low margin electronics, molecular level. And the third part is fill-in-the-blank schedule. Create that, find 10 factories that are capable, qualified, ethical. Really NDA them, release the RFQ, let them chew on it for a week, go visit them, come back, do an apples to apples comparison on the key components, and then from there, based on the financial data you have and then the visit, you should be able to select.
How do you know who's capable, qualified, and ethical?
Yeah, so the step 1 is figuring out who those factories are, and that's why we've spent a long time creating that database. That's step 1, and then step 2, which anybody, I couldn't more strongly encourage people to do step 2, is to go and visit the factory. There's no, even if you haven't done a lot of manufacturing, you'll have good instincts, and you may not be able to catch everything, but there's probably, if they're a bad factory, there's, meaning unethical, you'll see when you visit. You never want to work with a factory you haven't met the top management, you haven't met the engineers that are going to work on it, you haven't walked the line, because you'll get a feel that it's not good. And again, it's a superficial but important step. And then from there, there's like 10 other steps. You can do like how much operating capital do they have to be able to support your orders, and it goes on and on.
It's good to have a Chinese speaker with you.
Yes, yeah, I mean, definitely, we find we've got at Dragon about 20 people in China, and then all of us speak some form of Chinese, so it just, that communication thing is so important. So.
Could you just put that first slide up? You have the Skillshare address.
Oh, sure, of course. Yeah. There we go. You're welcome.
How do you build quality into your contracts? So if you have like a major defect, how do you decide who owns that cost? If you ran 10,000 units, they're all incorrect. Who has to swallow that cost?
Cool, yeah, so the question is, how do you build quality into the manufacturing service agreement? So it's definitely a longer answer, but the trick is figuring out who's accountable ahead of time. So you want to anticipate the problems you're going to have and come up with a solution so that when they do occur, like you're going to be under a lot of pressure with the schedule and all of this, that you can quickly say, all right, we talked about it, that one's yours or this one's mine. It's typically either a design issue or a manufacturing issue. Well, actually, typically it's a little bit of both. But if it's a design issue, then the company is responsible. It's manufacturing, the CM is responsible. And you'd come up with the remedy and also what classifies as a defect. So we'd often do like a 3% epidemic failure. So if there's more than 3% that have this failure mode, like the glue didn't hold the thing down, then that triggers a clause in the factory. Maybe it has to bring them all back and rework them at their expense. If it's less than that, then as a company, if I can keep track of, these 28 ones came back, then the factory should be able to replace them, either rework them or replace them. But yeah, thinking about what the different failure modes are, and then how to attribute that, and then what the remedy is critical. And like a normal MSA, I think ours are about 30 pages long. So, and you're talking like real money. Initially if you build 5,000 units, it's probably a couple $1 million, but as you start to scale it, these little words have tremendous impacts. So you want to find it. And find a lot of lawyers don't know how to, like, they're not dealing in the manufacturing side, so they'll either, often the pendulum swings way too far and it covers the wrong thing. You want to cover the right thing and the right level of detail.
For in-house hardware manufacturing, like you're building your own data center for providing some service, what is your perspective on cost, quality, and schedule? Like, how does it change? Because for consumer electronics, it's a completely different picture, and for you're building your own hardware to support some service.
Right, okay, so the question is, if you're in consumer electronics, I'll expand it a little, consumer electronics, medical data centers, how does the balance of cost, quality, and schedule vary?
Yeah.
So it's always still like cost, quality, and schedule, that's universal, but you would have different, you would emphasize different ones as being more important. So like medical, the quality is the most important thing, often schedule doesn't matter and cost is less relevant. For consumer electronic, unfortunately, they all matter. For like a McDonald's Happy Meal promotional toy, that it's all about, like, quality's gotta be good enough, but if the paint's a little blurred, as long as it's safe paint, it doesn't matter, it's all about the cost. But that's the trick, is figuring out, what vertical you're in, and then how to prioritize all of those. And then the trade-offs. Like, if I can spend $100 to solve a problem versus 10, that will greatly affect how I approach the problem.
Are there any good tools to like which actually kind of throw light on like all these different verticals, like with respect to manufacturing?
Yeah, that's interesting. We're building a platform that will do that, but it's not up yet, and I haven't seen anything else that would do it. I think often you'll get in like we're pretty squarely in consumer electronics. I haven't seen anything that ties together consumer electronics, medical, automotive, and so on. So yeah, it's a really interesting thing to see how they weight the three different parts of the piece of the triangle.
Can you talk a little bit about protecting IP when going to China and what you've learned? Is it possible, or do you give up on it?
Oh yeah, so the question is, how do you protect IP? Yeah, and I would look at that. China certainly has come from kind of a rough reputation, but wherever you build, you want to follow the same practices. So we look at it through two lenses. One is the different systems. So in any product, you probably have electrical, mechanical, and software. You can't protect the mechanical. If somebody wants to steal it, they're going to grab somebody to reverse engineer it. Electrical is a little harder to protect. Like, you could scrub off the silk screen of your components, but if somebody really cared enough, meaning there's enough economics behind it, they'll x-ray them to figure out where your traces are. So it's a little higher barrier, but they'll get it. What you want to protect is your software. And that's where you would use the bootloader. So just get a secured bootloader. If you're in China, don't do it in China, do it in Hong Kong. And a company like Avnet that has everybody scanned in and scanned out, no thumb drives, no phones. You give them the magic keys to the bootloader. They program that in the reserved part of memory, and you can sign that chip to the factory, because there's a problem with IP theft, but there's also the problem of a ghost shift. So imagine you're building 1,000 units a day, and again, you picked a great factory, but sometimes you have to trust and verify. You build 1,000 a day of your product, and then they build another 500 a night, and it's your product, but it's going to be competing with you when it goes out the back door. If you can sign the processor to them, you gave them 1,000 processors, so they can only build 1,000 units. So that's one lens. The other lens is on the management side. So there's 3 levels in a factory. You've got the bosses, the engineering managers, and the workers. The bosses, if it's a good factory, won't rip you off because they would lose every other customer they have and they'd hurt their business. The workers don't know enough. They're seeing the product right before it ships, so it's going to be a market. It's the engineering managers you got to keep an eye on. And again, cultures are different. Like, it's not a right or wrong thing. You can imagine somebody would approach an engineering manager back when we used to use thumb drives or CDs and be like, oh, here's $500. Can I have that? And that would be a real risk. So we find feet on the ground is important, need-to-know basis, good IP hygiene, so don't leave your computer unlocked. Have a secure room where people come and go, and really develop relationships with the team. So for all of our Dragon guys, we've got our team embedded in the factory day in and day out. Not that it couldn't happen, but everything is risk management. The chance of it happening is much lower than if you're sitting over here visiting China once every 4 months. It would be really difficult to know what's going on. But yeah, IP is incredibly important. And, like if you're building sneakers, my heart goes out to those guys because there's no processors. They're going to be knocked off left and right.
So any kind of cloud-enabled IoT device is going to have a huge advantage.
It's huge because each one will have probably a unique serial number. So if you see like 50 instances of number 205, you're like, all right, that one's bad. We have heard of one of our customers, I'll keep nameless, has a really good sense of humor. So they got knocked off by a Chinese firm and saw these 3D printers loading up to the web. And rather than, and it was important that they communicate through the cloud, otherwise it wouldn't work. Rather than shutting them off, they introduced an error in 10% of them. So every 10 times that machine would fail, and it just drove them crazy. The users were just out of their mind. Why is this not working? So there are ways to get revenge. But yeah, definitely cloud is good.
I spent an inordinate past life trying to charge these factories. And you talked a little bit, but it might be useful to talk about the value of the visits over here at the win and the face-to-face meetings those guys.
Yeah, that's a great question. So the question is, when is it appropriate to, when is it good to visit a factory in China or any factory? And with the manufacturing, like it's building something with a relationship, and we're huge fans that the journey should be enjoyable. It's not just the end product, but it's the steps that you get there and the people that you meet along the way and the relationships you build. So that's incredibly important, especially you're going to have really good days and you're going to have really, really bad days, often on the same day. And if you haven't built up that relationship with the factory, it's going to be really hard to get it done. So we find absolutely when you're doing the RFQ to pick a factory, you want to meet everybody over there and see, like, do I want to work with this person? Do I think they're going to be with me in a bad time? Is there chemistry there? Then we'll have the team go back for the handover. So like, all right, I pick factory A, here's the handover package, sitting down for about a week saying, oh, why did you do this way? Oh, I did it because of this, so they can learn the history. Then often add what's engineering pilot 1, which is where you get the plastic and the boards put together, because there's a lot of debug, and that's sort of where it first comes to life. And having that high bandwidth connection and the domain expertise of the US team sitting down with the manufacturing team is something that's difficult to do over email. And it's also a really big milestone because that's sort of your really early stuff. And then depending on how it goes, every EP, and then we go into, an EP is engineering pilot. And you've got FEP, which is final engineering pilot, which is a saleable product, but built by a skilled team of engineers in the back room. And that's really where you sign off and be like, yeah, if we can build it to this spec, we're good to go. And it's much easier just from, again, thinking of schedule, having that in-person conversation. And then at that point, the visits can get less frequent. Usually you have a production start where you hit the big red button and it starts cranking out, and then maybe periodic visits after that. We find this is also kind of what we do with the Dragon customers, predicated on feet on the ground at all times by the Dragon team. If you didn't have people you trusted on the ground, you probably want to make those visits much longer and much more frequent, or even send one person over there. Like that's what I did at iRobot, is just moved over there for 4 years, which is a phenomenal experience, but it would be very difficult to do now, and it would be very hard for most companies to do it. But yeah, it's a great question in that it's not, you're building product, but it's really the relationship that's going to get you there.
Do you see any other place viable to manufacture other than China?
Oh, absolutely. Yeah, so the question is, do you see places other than manufacturing as viable geographic solutions? China, I love if you're building 5,000 or more units. It's a terrible place in general to build if you're doing less than that. So there's kind of 3 steps. One is under 1,000, your dining room table is great. 1,000 to 5,000 is a nightmare. And then 5,000 or more is China's good. You could also look at Mexico. So if you're building a refrigerator that's huge, you don't want to pay to ship that from China over here. It's much easier to bring it in, and it's a lot easier to speak Spanish than it is probably to learn Chinese. So that would be a product geometry-driven thing. If you want to build less than 5,000, I love building locally. It's so much easier to speak in the same language, the same time zone when you're right next to each other, saying, oh, that doesn't really go there. I wanted it to go over here. So every product you'd want to look at carefully. But for consumer electronics, which is most of what we build, the domain expertise, the supply chain, the capability, the infrastructure in China for high volume stuff is in my opinion, second to none. But again, I wouldn't want to build 5,000 units in China. It would just be, the overhead of dealing with it wouldn't be worth it.
So currently, there's no competition for greater than 5,000 units to China.
If you're doing, I mean, Mexico is very viable if you're doing, it's certainly big things. A lot of TVs, like I would look at, consider that. We see lower cost manufacturing bases like Vietnam, a little bit Cambodia, India, but they're more, the problem that we often see there is you've got to ship the components in, which adds time and cost and risk. If you're building a garment like a cut and sew, then I wouldn't do it in China unless it's a cool startup thing where you use your phone to take a picture of somebody and figure out their size. But for that, like Vietnam is awesome because it's a lower cost labor base. The price is half of what it is in China. So yeah, it does depend on what you want to do, but my point of view is skewed towards higher volume consumer electronics.
Obviously, we were talking before about IP problems in China. How does that compare in Mars or other places?
Yeah, I don't have, so the question is how does IP in China compare with other places like Juarez? I don't have, I have academic understanding of Mexico, but I don't have thousands of hours of feet on the ground. I would look at applying the same principles everywhere, and I don't, China sort of has a bad rap for IP, but we built hundreds of millions of products and never had a problem. But I know given our location here, folks may have quite a bit more experience in Mexico. If any, I'd certainly open it up to the people here that have built a lot of stuff and some differences in Mexico than we see here, or if you want to circle back afterwards. Cool.
Can you talk a little bit about Dragon Innovation and where the sweet spot is for companies to come and visit you?
Sure. So the question is to talk a little bit about how Dragon works in the sweet spot. So yeah, what we can do the most to help is companies that have a working prototype, bill of materials, and CAD files, and want to either get ready for a venture round or crowdfunding. And then from there, an RFQ to pick a factory. So solving that problem of how do you find those 10 great factories and how do you narrow it down to one that's going to be a great partner. And then once you've got that, then all of the project management, design for manufacturing, assembly, creating the quality plan and implementing it, costing and sourcing to find short lead time components that are at the right price, and then negotiating the manufacturing service agreement. So it's sort of like an API for manufacturing. And we can work with a bunch of different companies, but if you're building 5,000 or more units, that's definitely our sweet spot in the consumer electronics. But if you're not, we'd love to, we know how hard hardware is, having lived this for a long time. So we've tried to put out a bunch of resources. So I was lucky enough to be a professor over at Olin College of Engineering and taught machine design and design for manufacturing assembly. So if you want to learn about injection molding, we've got a bunch of videos and slideshows sort of explaining how that works, or stamping or die casting or anything like that. And really, even if it's not a perfect fit for Dragon, an effort to help out the community, to shed some light on the stuff so that companies can sort of get ahead faster and build some really cool products.
What's the biggest mistake? If you had to look at all the things you've seen, what's the biggest mistake you see crowdfunding products make?
Okay, so the question is, what's the biggest mistake crowdfunding products make? Yeah, I mean, it's basically getting out too far over your skis. So everybody, when they do crowdfunding, just wants to raise as much money as they can. They're focused on that, and yeah, we'll figure out manufacturing later. But the problem is, as I look at it, like crowdfunding is like a chainsaw. And I really, late in life, got into chainsaws, and they're just awesome tools. You can just make such short work of anything. But if you use it wrong, you're going to cut off your leg. So with crowdfunding, where companies fail is they don't understand cost of goods sold. They don't understand they have to pay for the tooling, that they may have to go to China or build here, and what's involved in that. They often promise too soon of a date, and they think that getting one working means they've got a path to get many of them working. So you'll see them create these really compelling videos with great products, but promise their mouth is writing checks their body can't cash, to use the Top Gun thing. So then they get funded, everybody's like, that is awesome, when can I have it? And then they realize the hard truth that their cost of goods sold is $40, but they're only selling the product for $30, so they're going to lose $10 in every one they sell, or that there's all this stuff to do they haven't thought of, so it's not going to be a year delivery, but it's going to be 2 years delivery. And at that point, like, people have given them hard money, there's expectations that your best backers will become your worst enemies. So unfortunately, we've seen that backlash all the time. And that's where we've got one thing called Dragon Certified, really focusing on helping companies get set before they crowdfund, so that when they are funded, they've got a clear path to deliver on their promise. But yeah, crowdfunding is an amazing tool, but I think of it just like a chainsaw. One more question.
If you are planning on doing large-scale manufacturing, is it a reasonable strategy to do like an early run locally and then plan to move to China for the larger scale?
Okay, so the question is, if you're planning high volume, does it make sense to build a smaller batch locally and then go someplace else for mass production? So there's sort of 3 ways you can do it. You could try to build all locally in scale. You could build overseas or someplace that's not here, or you could do the hybrid. And it really depends on, one, what is your ultimate volume? So if you're confident we're going to build 100,000 of these, I would start picking a factory that can help you scale to that high volume. Because otherwise, if you build locally, it hits and then you have to scale. When you move, you can't move your tools easily. We use mud frames over here in China. They use mold bases. It's like VHS and Beta. That's the right analogy. Like, they both do the same thing, but they're not compatible. So just as you've got the most pressure to scale, you also have the biggest hurdle that you've got to start all over, and you lose all that domain expertise. If you knew you're only going to build 5,000, I'd build locally. And in the middle, which is where most people are, the trick is figuring out, finding the right factory that will build what you need. I would imagine it makes sense through Proto Labs or Advanced Circuits and then the dining room table, or great local factories here to build, maybe 500 or so, so that you've been able to de-risk, debug quickly. Because there is a lot of overhead to building in China that you pay for up front, but the advantage is you can scale quickly. So you kind of want to know your volume curve, and then your ability to find those factories. And also your cost structure. It's typically, not always, but more expensive to build here. So if your product was one that couldn't absorb that extra cost hit, you may think about that someplace else sooner. So yeah, there's a lot of different variables that go into it.
I would say it's your confidence in your design, right? Because if you're highly confident, go for it. If you're not confident, you got some bugs to work out. You want to prototype a lot more.
Yes, yep. Yeah, I mean, and we think of as things get further, like the early decisions you make cast a really long shadow. So if you pick a processor that's not capable and have to switch it later, that's going to be insanely painful, because you probably bought you bought a lot of them that you can't, there's no returning stuff. In China, you got what you got. So yeah, if you're confident, then you could be a lot more aggressive. But if you're not, then being closer and more conservative would be smart.
Displays, batteries, in the chipset. Those are the things to watch for.
Yep. Yeah, I mean, it's all the early decisions cast really long shadows, so you want to get those right.
Any custom batteries, lithium batteries, takes a long time to get. They're long lead time items. They have to be specifically tested. So
yeah, I mean, it's amazing. With the Roomba, we used to buy 12 million cells a year, and they're all custom made. Like the particular.
It's the first ones that take the longest time. Then they can repeat it, but you want to get it.
Got to get it baked right. Cool. Well, I know we kind of ran long, so let me wrap up here. But thank you, and if you want to talk further, I'd love to.
We still have some time, so just want to open the floor. I know a couple people are visitors, they want to say hi, and then we'll have some time to finish the rest of the pizza. And just a favor for your benevolent organizer, please just clear the trash around you, even if it's not your own. Make sure no one's actively drinking something, don't tear anything from someone's hand. But thank you also to Capital Factory and the people who help clean up as well. So I know we have a couple visitors here. First one's hand up, I want to hand the mic to. I was just going to give it to you anyway.
Come up there.
Yeah, come on.
Hey guys, my name's Chris Shao. I want to introduce myself. I'm a principal at Gossamer. We're a hardware venture company that just started in Dallas. Quick background about Gossamer. We're a company that's about 12 people. We all have aerospace backgrounds. Stress engineers, design engineers, and manufacturing specialists. I myself am a stress engineer. I've been that for about the past 10 years. Half of my career was on the Boeing 787. I've also done drones, flight test vehicles, some defense projects. And the purpose of Gossamer is to basically leverage our aerospace engineering experience to help startups or established companies create consumer goods.
What's your website?
Oh, it's gossmr.com, because I don't have the money to buy Gossamer.com. It's like $3,500. But if any of you guys want to come and talk to me about what we might be able to help you guys with, just come up after this.
Hi, I'm Darius Sathiram. I'm with 10X Precision. We've been a design house in Austin for a long time. We do a pretty diverse range of things, from consumer electronics, we do some medical, a lot of industrial oil and gas is pretty common, some military projects every year. So just wanted to introduce ourselves. We do a lot of low power wireless. We've designed products that have been in production for a very long time. Some of you have probably heard of iFetch, the little dog ball thrower. So we did all the electronics on that. We tend to not get as far into the manufacturing as Scott does, but everything you said has happened and will happen again. In fact, currently one of the iFetch products is ready to hit production, and of course they found a last minute issue, and there's all kinds of panic going on before Christmas season, so all pretty familiar stuff. But yeah, very few folks, we work with startups quite often, and if any of you folks want to come talk and just discuss an idea or a project, we're happy to talk to you. We don't charge for that.
What's your URL?
It's 10xp.com, tenxp.com. So we're a team of 6 engineers and a couple of contractors. We do everything from hardware design, firmware, FPGA design. We do a little bit of the Windows stuff, but it's really more for diagnostics and factory test. We often end up building the fixtures that go to China, that the products get tested. So you might see restaurant pagers at some of the newer, a lot of the restaurants now with a company called Long Range Systems. So at Chewy's, they just started shipping, so they'll be building about 100,000 of those a year. So we designed that product last year, and it will be one of the higher volume products. Cool, thank you.
Hi, I'm Zayd Hussain, and I'm here for MakerArm, and we are Dragon certified. So my co-founder, Azam, was actually in Shenzhen, and Scott has been advising us, and it has been a wonderful process. He's just taken all the mystery out of manufacturing, and it's been great working with Dragon. So I highly recommend anyone who's thinking about it, please talk to Scott and just work with Dragon. It's been wonderful. So we have a current Kickstarter campaign that's going on for MakerArm, which is a digital fabrication system designed as a robotic arm that can 3D print and mill and laser, pick and place, assemble, has a lot of functionality. So please look us up, and any social media mentions would be very, very helpful. Thank you so much.
Omar, you know I'm going to pick on you. Omar, will you come up and introduce yourself?
Good evening, everyone. My name is Lamar Baines. I'm the president, founder of Creative Hardware Staffing Solutions. Creative Hardware Staffing Solutions is a dedicated hardware staffing company. So we provide engineering contractors, embedded systems, chip design engineers, SoC engineers, and CPU engineers to hardware startup companies. And so our model is to provide hardware startups with engineering contractors. And so if you have any needs for engineering contractors, come see me.
Anyone else? Come on up.
Hello folks, I'm Mark Emanuel. I'm the general manager for Tech Shop up in Round Rock, in the Lafayette, Ontario area. Just want to invite you all personally out to an open house we're having on Saturday. Maker Arm's going to be there, Zach's going to be there showing off some pretty nifty tools that she's bringing to the market. And if you haven't been up there in a while, we're making some upgrades to the shop. We're bringing in some new gear, and we want to give you a chance to look at all the equipment that we've got available that you can use for rapid prototyping your initial product design.
What time's your open house?
11 to 4. 11 to 4 on Saturday.
Hey, how's it going, folks? First time here at Makerspace. This is Space right here, so thanks. My name is Marco Cortinata. I do a lot of things. My mission in life is to leave this place better than I found it. I'm sure that's relative, better, right? We can get into that. But all right, so really what I want to do is I want to bring window washing drones to Austin. Don't have any experience in manufacturing or electronics or any of that sort, but it seems like a lot of you do. So if you want to collaborate, collaboration is key. Let's make this happen. You can reach me at marco@sanitationproject.com. Great.
Hi everyone, my name is Anand. I work with the company Venkill. We're a surface mount passive company in Austin, Texas. We've been in business for 29 years. We supply ceramic capacitors, resistors, inductors. One of the cool things we do is engineering kits. So we give them free. They're 3-ring binders. So if you guys use 0603s, 0402s, we'll give you free kits. Our resistor kit has, I think, over 180 values. So it's nice to, when you're breadboarding, kind of just plug and play. And we do that for free. We have supply chain solutions. We have engineers on staff that can help you. We supply to all the big guys, the Foxconn, Flextronics, Benchmark, Sanmina. Also to all the local guys like East West, Kodiak, Vario up in Dallas. So if you guys need any samples or any, excuse me, BOM costing, we can do that for you. Thanks.
Anyone else? Yep.
Hey guys, I'm Ryan. My husband also is named Ryan back there. It's an easy way to remember us. We run a 3D printing company here in Austin called Solid Prototype. Some of you I know have heard of us and have been with us for a while. If you're not familiar, we are here locally. We can provide what we specialize in is polyjet printing. And we can usually get your stuff out to you hopefully next day, depending on size and quantity, of course. We were absolutely blown away by your stuff. We watched it today at the office.
Thank you so
Very
much.
amazing stuff.
That's good to hear.
And so if you have any questions or thoughts about that, here we're locally. And we are also kind of partnering with a few other local manufacturers, kind of on the smaller run type stuff. So just know we're available and we're here if you have any questions.
What's your website?
Oh, the website's solidprototype.com.
Anyone else? All right. Feel free to enjoy some pizza and drinks. And we have the space until 8:30. So thanks again, everyone, for coming.